Let's see here. Solve for x. And you guys using the first strategy of every student, the stare technique. So first thing to do is convert this to exponential. The base comes over here. So we have 2 to the power 3. The log drops off, so we have equals to 1 minus 2x. 2 to the power 3 is 8 equals 1 minus 2x. Subtract 1. 7 equals negative 2x. Because that's a negative, change the signs of both sides. So we have negative 7 equals 2x, then divide by 2. And there's your answer. Everybody okay with that? Okay, let's try one with logs on both sides. Log base 5 of x is equal to log base 5 of 9. Stop. This is you're going too far. What do we do with this coefficient here? It becomes an exponent. So we have log base 5 of x squared equals log base 5 of 9. Since the logs are the same on both sides, the only way these can be equal is if x squared equals 9. Square root both sides, x equals plus or minus 3. Is that a right answer? No. What's the domain of logs? What does the graph of a log look like? You cannot have negative x's. So the answer is x is equal to positive 3 only. Log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. Path, I hope. First step, combine the two logs on the left side. So it becomes log base 5 x plus 6 x plus 2 equals 1. What'd you do next? We can multiply these two together, which will give us x squared plus 8x plus 12. Boiling x times x, x times 2, 6 times x. Yeah, everything was doing great. Now we have to get rid of the log. How? Right, so we have x squared plus 5x plus 12 equals 5 to the power of 1. Subtract 5 from both sides.
Oh, you gotta get it all on one side.
Has to be equal to 0 since it's quadratic.
That's why I messed up.
12 minus 5 is 7. Can we can we factor this one? What times what is 7 when you add them you get 5? Oh, it's 8x. Where do we get 5 from? 8x. Now we can factor it. So it's x plus 7, x plus 1. So my solutions are -7 and -1. True?
Yeah, so I could have done it in my head from the very beginning. I just didn't know there'd be more than one solution.
Well, there isn't. If
It'd be.
if we put -7 inside here, what happens to this? If we put -7 here, it comes, you can't take a log of a negative number, so this one we can't use. So this is the only answer we got. X equals -1 is the only one we have. You have to make sure you check the answer when you plug it back into the equation. You cannot take the log of a negative number because we only can use positive x's.
Okay, that part makes sense.
And only that, but we can look at this and we can tell the domain. The domain of this equation is x has to be bigger than -6. Because when x is -6, we get 0. Can you take the log of 0? No, because there you cannot take x cannot equal 0. X has to be greater than 0. So x has to be strictly greater than -6. So that's the only answer you got. Which one was that? Oh, let's try another one. ln x equals ln x plus 6 minus ln x minus 4. What's the first step? We can do this side. Makes it a fraction. So we have ln x plus 6 over x minus 4. Since we have ln's on both sides, x equals x plus 6 over x minus 4. Multiply both sides by the denominator to get rid of the fraction. And that's usually a general rule. Whenever you have equal sign and a fraction, get rid of the fraction first. Multiply everybody by the LCD.
I thought about doing all that, I just didn't do it.
Why not?
It was throwing me off, I didn't know to cancel it out.
If it's the same thing as if m equals n, then ln m equals n. So if as long as the operations, if there's the same exact logarithms, all you have to do is compare the answers, the numbers. So since the ln's on both sides, the only way they can be equal is if this equals this. So we have x squared minus 4x equals x plus 6. Subtract x, subtract 6. So x squared minus 5x minus 6. The signs are opposite, and the bigger number will have a negative sign. What times what is 6 when you subtract them, you get 5? 6 and 1. 3 minus 2 is 1. That was our opposite signs. So when we solve this, which one can we not use and why? Because of the ln x, we cannot have a negative. X cannot be negative. So this is the only answer we have.
Or, yeah, if you put a -1 in the denominator, you get a negative number, which returns the whole fraction negative.
Well, always check it in the original question. The original question says the domain says for this one, it's got to be bigger than -6. This one's got to be bigger than 4. This one's got to be bigger than 0. So I cannot use, because of that, I cannot use negative numbers. Let's look at this next one. Look at it 2 different ways. Let's look at doing this 2 ways. Because one way is going to give us an answer that we have to think about. The other way is going to give an answer that has to be the answer. So this first one. If we just take this one and move that over, so we get x squared is equal to 3 to the 4th, which is x squared is equal to 81. How do we get x by itself? Square root both sides. So whenever we do that, we have to put it plus or minus in the answer. Because of that, we have to check both of those answers. Will they both work? The answer is no. You cannot take it of a negative number. Even though it's squared, you cannot plug it in there. Let's look at this other way. What if we get rid of the 2 first as using the properties? Because our next step would be what doing here? We're solving for x. We have to get rid of the 2. How? Now the only way we can do it. If we follow the properties, it will restrict us from having multiple answers at the end.
Oh, that's pretty cool.
Yeah, it's just a safety measure. Because even though there's a quadratic equation, we cannot put the values in there. If we graphed it, remember the graph of a logarithm has to be a continuous function, increasing. We can't have a -9 in there as well as a +9 and expect it to be. because we cannot cross the y-axis also. Look at the next example. Here's the theorem. If a to the u or a to the m equals a to the n, if the bases are the same, then the only way they're equal is if the exponents are the same. Solve for x. We started off talking about exponential equations. What's the inverse of exponential equations? Which one? Logarithms. If this equals y, then the log base a of y is equal to x. The conversion. They're inverses of each other. So we have to somehow put it into logs. So the way you get rid of the exponent is typically if we take the log base 2 of both sides. The exponent goes out in front. Then we have log base 2 of 2. What is log base 2 of 2? 1. So we have x is equal to log base 2 of 5. But we can't do anything there. We still don't know what x is. So we got to use a change of base. ln5 over ln2. There's our answer. We plug that in the calculator and it'll give us an answer. But there's another way we could have done it. We had 2 to the power x. What if we took the ln of both sides? Because what does the ln do? The ln takes the x, the variable from the exponent, and puts it where? It puts it in front. It puts it back into the equation. Now to get the x by itself, I divide by ln2 both sides. That's the same answer. So that's the whole purpose of using the ln, is to get the x out of the exponent back inside the equation. We can use it. That's the only way we can get it out of the exponent.
Move it to the prime now, but let's see, move it to the prime. And I'll put L in, but I got all the way to x equals L into 5. Now
You're here or here. Okay, well, that's not bad. If you got that far, that is a true answer. But if it asked for a specific answer, you couldn't go any further. So this is a good answer. I think the computer will take that. But if you want to know the exact decimal answer, if it says put your answer as a decimal, you can't do it with this. You have to convert it now with the change of base, which is the whole purpose of the change of base is so you can get a final decimal answer. Okay, B. 8 times 3 to the x equals 5. Work that one out for me. What's my first step? Multiply by what? We're trying to get x by itself. So we have to get rid of the 8 first. We have to divide by 8 first. So we have 3x equals 5 over 8. Now, what we can do is let's take the ln of both sides. What's going to happen on the left side? If we take the ln of 3 to the power x, this exponent goes out in front. What happens here? How can I expand this? Because it's a fraction, I could subtract them. So x is equal to ln 5 minus ln 8 over ln 3. There's my answer. And if you want to know the exact number, just plug it in a calculator and punch enter. Get that? Where everybody go on these?
The Ln5 over Ln3, but I didn't have the minus Ln8 in the numerator because I didn't do
This.
the 8 in the very beginning.
What'd you do with the 8?
I didn't do after that. Let me see. So I kind of ignored it and I was like, I think a 3 to the power of x equals 5. I turned that into ln 3x equals ln 5. And then I put the x out in front of ln and that became 8 times x.
Oh, okay. You put it at the very, okay. No, the 8 had to have been stay throughout the entire transition. So you had 24x? No, actually, that is a good question, though. That is a very good question. What if I had this instead? A lot. What is 8 made up of? Which is 2 times 2 times 2, which is 2 cubed. So this could be written as 2 cubed times 2x. So this one could have been 3 plus x equals 5. Now when I took the ln of both sides, I got 3 plus x times ln 2 equals ln 5. Divide by ln 2. So we have x plus 3 equals ln 5 over ln2, subtract 3. So x is equal to -3 plus ln5 over ln2. That makes a big difference. If you can get the same bases, you can combine them. That's a big plus. Makes it much easier, I think.
But you don't have to, you can just solve it like you just have to solve the other one.
You don't have to, but you get the same answer. If these two bases are the same, it'll get you the same answer at the end. It's just that this way will be a couple of steps shorter than the other way. But again, if you follow the properties, you can't do anything but get the right answer. Okay, you think those were easy. Now, how do we solve this? We only have one more example after this, and we call it a day. What's my first step? I have to get rid of the exponents. How? Take the ln of everybody. Because that's the only way to get rid of the exponents, bring them down, is if we take the ln. So that means this goes out in front, this goes out in front. So we have x minus 2 ln 5, 3x plus 2 ln 3. What are we solving for? X. So we have to get, since we have x's inside the parentheses, we have to get rid of the parentheses. So we distribute. So we have x ln 5 minus 2 ln 5, 3x ln 3, 2 ln 3. That exponent we could bring up there, and this one we could bring up there, but the other ones are x's. It's got to stay there. So it's going to be x ln 5 minus ln 25, 3x ln 3 plus ln 9. Now we have to get the x's on one side and everything that's not an x to the other side. So let's move this x to this side and this to the other side. We did something not too long ago. No, we did something like this similar to this not too long ago. So that one becomes a minus 3x. Then this one's going to be ln 25 plus ln 9. We can factor out the x here, so we have ln 5 minus 3 ln 3. These, since they're addition, I could multiply them together. The 3 goes up there. Three cubed is 27. What can we do with this? It's minus. So it becomes a fraction. So now I have to divide both sides by that. I could either leave it like that, or I could leave it like this. Either one of these will work. This one looks cleaner because we don't want to have a fraction. So that would be our final answer. All we're using is the 6 basic principles of logarithms. One more problem. How would you solve that one? We can't do what we've been doing because we have too many x's up here. We can't take the ln of the whole thing.
If it equals 0, then it doesn't have to be a quadratic.
Or some polynomial equation that's we always said equals 0. But is this quadratic in form? So this is 2 to the power 2. So we have 2 to the 2x minus 2x. So it is quadratic in form because this exponent, if you multiply it by 2, you get the leading one. So it is quadratic in form. But how do we solve it now? To solve, use substitution. let's say u is equal to 2 to the power x. So since u equals 2 to the power x, that means this one is u squared. Plus 2 to the power 2x is 2x squared. Now we can go ahead and factor this one out. Opposite signs. The bigger number gets the negative. So what times what is 12? When you subtract them, you get 1. 3 times 4. So the bigger number gets, so it's 4, and that's 3. So we have u plus 3 equals 0. U minus 4 equals 0. Remember, u is 2 to the power x. So now we solve these like we normally would. So we have 2x equals negative 3, 2x equals 4. Can 2x equal negative 3? No, so we can't use that one. Take the ln of both sides. So x is equal to ln 4 over ln 2.
How do you go from that to that? X ln 2 equals ln 4, how do you go from that?
Because, well, the x goes out in front. That's, now just divide both sides by ln 2.
Okay.
That's that. Pretty straightforward. Be very careful. Is this the same as this? ln 4 minus ln 2? No. Because that's only if I have m over n. Only one logarithm. So this is ln 4 over ln 2, whatever that is, that's your answer. That's the end of that chapter. Now, when we come back next week, we're going to do trigonometry for the next 6 sections, next 3 chapters. So bring your trigonometry stuff, those the cheat sheets I gave y'all. Bring those. Okay, I'll bring a bunch next time. All right, everybody. Have a great, safe weekend. Enjoy the allergy season.